First we have to double tap this icon Chromium 7 to open it. Now this screen will display over your system. This is the previous data of calibration which is stored and provided by the thermoscientific Hplc company. Now we will select this data by double clicking it. This screen will open. Over this screen, it shows here chromatogram, calibration plot, interactive results of each peak. In results, we have the sample name, retention time, the time by which the peak appears to its maximum height. Area of every peak, height, the plates, theoretical plates. Here it is relative standard deviation, which is known as RSD. Here are some view settings. Injection list. It will show the sequence or batch which is already completed. What is sequence? Sequence is the batch consists of sample name, injection volume. It may be 2 microliter, 4 microliter, 8 microliter, up to 100 microliter it can be. That means the injection will inject the quantity of sample in microliter. It consists of processing method. The method through which we process the data which is completed and ran through the instrument. It comprises the instrument method as well. What is instrument method? Instrument method consists of instrument parameter details. For example, the flow rate of mobile phase, the pump pressure in bar or PSI, column temperature, column oven temperature, sampler temperature, detector wavelength, nanometer. So the sequence comprises all these columns which will command to the instrument. This is the instrument method. Through here we make the instrument method. These are the components: acetanilide, acetophenone, propiophenone. These are the components. It will show here peak properties, peak name, retention time, that it just retentioned at the time of 0.170 minute, peak width, type, height, area, amount. These detail it will show here. This is the integration site. Here in detection, we can add the parameters through which we process our data by filling the minute of start time and end time, and we can add the name of every peak. This is the process of naming the peak. It consists of component table. Here we put the name of every peak at their specific retention time. So it will show their name like acetanilide, acetophenone, 3-propiophenone. Here it will show audit trial. Whatever changes we will make, it will appear here. This is our report designer. Here we will get our report here. Here it is showing the peak name and its status, slope, correlation coefficient, variance of every individual peak. To make the new sequence, you have to select create option here, then sequence. Then it will show the instrument ID, which is here QCD Hplc 004. Then click over next. Then here just put the details of the instrument related columns like name, type, level, position. Here it is showing some mark. Empty value is not allowed. So here we put the injection volume of 10 microliter. And here we got the column. So here put the name of the sample, whatever paracetamol, whatever is your sample name, you can put here. Here what is the sample name? So what is the type of the sample, whether it is blank or standard or sample. Position of the sample vial, like integration on off, threshold, recent baseline, width, valley to valley. After selecting those methods from the browse, select the next option and then again next. After putting the specific comment, select the finish and it will automatically save. Here I am not saving the method as I haven't made any, so I just close it. For making the method, just go on the instruments and here you can see the home. Over the home it is showing lamp mode standard, signal. If the system which has been already in connection with the here the instrument is not connected to the system, so whatever the connection which is already ready will appear in green color in this icon. For putting the value of pump, we go over the pump icon, which is here showing not ready because the system is not connected with the instrument. And here we can add the flow per pressure, that means ml per minute, the flow value. The module is not connected, it is showing here as this is not connected with the instrument. So this is the eluent, which is our mobile phase ratio of the reservoir A, B, C and D. From the different 4 bottles, we can carry out the solvents in different proportion and ratio if it is in case of gradient, but in case of isocritic, the solvent will pass through the pump from the one bottle and which will be of 100%. Here it is showing audit trial. Here sampler. In sampler, we will put the temperature of the sampler port. Column composition. Here we will put the nominal temperature ready delta, equilibrium time, which will be provided in your standard test procedure. So by seeing that procedure, you can fill all the criteria. These are the detector: UV detector, fluorescent detector, reflective index detector. These are the detector. Here we put the nanometers of the detectors. Here UV visible detector are of two type, UV1 and UV2. These are our sample port. Here we put the sample and can easily recognize from here. So I have shown you how to create sequence, method, and how can we operate the Chromeleon 7. For getting more about the data processing system, so how can we get the data after integration, just be on my channel. This is the Hplc system. This is the reservoir, which consists of mobile phase bottles. Here you can easily see A, B, C and D tubes are dipped in the mobile phase bottle. Here these are the suction filters which filter the mobile phase before letting it through the column. This is the detector, UV detector. This is the connection of the detector to this column port. That means the detector will connect through this column by this tube, which is called as detector end tube. This is the sample port, which carries these trays of sample, and here we put the sample vial. Here inside the injection is there, which inject this sample. How much will it take the injection volume? It will be prescribed or defined in the sequence. That's why we make the sequence, as it will shows how much mobile phase, how much injection volume, how much temperature for the system we have to regulate. And this is the pump which mix and pumps out our mobile phase into the column. This is the column port. Here we put the column. This is the detector end of the column. This is the injector end of the column. Here the injection will inject the sample and passes through this end, and the sample will pass through this end to detector. This is the column, make of thermoscientific. It has given the part number, lot number and its dimension. It's of 250 mm with diameter of 4.6 mm and its particle size is 5 micron, which is very important to observe before initializing any sequence through the system to instrument. So we will stand it like this to head the arrow in the upward direction. Column comprises of the stationary base made up of silica gel gypsum, which consists of stationary layer which is made up of liquid, which may be of polar and non-polar. Phase will pump out through the pump to the column, and the sample is injected through the injection and entered into the column. Sample will move over the stationary phase with the help of mobile phase, and the sample will work on the principle of adsorption and the partition. Then it will reach to the detector, and there it detects into its components.